Hello and welcome to this video on how to solve a system of inequalities. When we start about talking about a system of inequalities, I want you to think back to when we've talked about a system before. And that's when we dealt with a system of equations. And I have an example of a system of equations over here at left. All right, so I've got two equations here. And remember, a system of equations is when you have more than one equation and you're trying to find any of the solutions that make both equations true. Now, when we dealt with a system of two linear equations, we found that there was only one point where these two equations are true, and that was my intersection point. That was the only point that was on both lines. And remember that any point on the line is a solution to the equation. So any point on this blue line is a solution to the equation y equals 2x plus 1. Any point on the green line is a solution to the equation y equals negative 2/3 x plus 9. And when we're looking for a common solution, there's only one point that is on both lines. Now, we also notice that sometimes you can have unique cases where the two lines are parallel, and so they'll never have any points in common, and there will be no solution to the system. And we looked at a special case where there's an infinite number of points that they share in common when the two lines are coinciding. In other words, they're the same line, so they're one on top of the other. That is solving a system of equations, and we learned how to do it algebraically and graphically. The graphically part is the part I really want to focus on because that's going to transition into our system of inequalities. So again, to just keep in mind, the solution to a system is the point or points that make every equation in that system true. Okay? Using that idea, the same thing applies when we go to a system of inequalities. Now, a system of inequalities is simply two inequalities at the same time. And so we'll start by just taking this first inequality, and you should know how to graph this linear inequality. If you don't, go back and watch those videos. But if I have y is less than 2x plus 1, I'll start by plotting all the points as if this was just y equals 2x plus 1. But then I look at that inequality symbol. This inequality symbol right here tells me what type of line to use in order to connect this. And I'll just remind us that this time here I will use a dashed line, all right, because it is not allowed to be equal to. And then after that, we test points on either side, or you examine the y-axis to determine which side I'm going to shade. So I notice here I have y is less than, and so if I take any point on this line and I go less than, my shading is going to be less than those points on the line, giving me shading that is completely beneath our line altogether. All right, so that's how we do one. Now, a system of inequalities is when I introduce another. So let's look at the second one I'm going to introduce. What if I have y is greater than or equal to negative 2/3 x plus 9? Well, if this is the case, I'm going to plot the points as usual as if it was y equals negative 2/3 x plus 9. And then I'm going to decide what line to use. All right, and the line I'm going to use here, because of this symbol, greater than or equal to, is going to be a solid line. Again, I remember that because it's a nice solid line under the sign here. And then I'm again going to use this symbol to determine which way I'm going to shade. You could test points on either side or examine the y-axis. Here, y is greater than my equation or greater than my line. So this point right here, going up is greater, up is greater, up is greater, and so on, making everything above my line what I'm going to shade. Now, a system of inequalities is when I take both of these inequalities and graph them at the exact same time. Now, if you notice here, the overlapping region, you can see I've got solutions. I'm going to point out a few solutions here. I'll do this in green first. Up in this region right here, all right, that is my solutions for everything green. All right, everything in the green inequality is what I'm looking for there. And then I've got my solution down here in this region down here. This is my solution for everything to the blue inequality. All right, I've got this section over here that has no shading whatsoever, which represents no solutions to either of the inequalities. And I've got my final section that I want to focus on, and that is this section right here. This section is where both of my shading regions overlap. This is going to be my final solution region. Now, notice I've shaded and I can see the cross thing. If you're drawing this and you keep things nice and organized, you can do that. Or you can ignore all of the original ones. I'm just going to erase all of the original shadings here. All right, so I can take all of these out and kind of just examine this area to understand where I'm going to shade. And I'm going to take that out there. And then this one here and up in this direction there. Now, and then I just get my final shading region here. And I'm going to pick, I'll go for red here. And you can just shade in the entire solution region here where both of them overlap, because that's the only focus on a system of inequalities. I just want that section where both of them overlap. I don't care about the individual ones as much. I'm looking for the solution to the system. All right, now in this area, any point in that spot will make an equation true, and I'll just pick some random points here. All right, that will make both inequalities true. That point there will make both inequalities true. That point there. But let's talk about some of the unique points. What about that point right there? Well, it's on the solid line bordering the shaded region, and therefore it will also make both inequalities true. Because notice this point is less than the blue inequality, which means it'll make my first inequality true, and it's equal to the green inequality, and so it will make the second one true because it's allowed to be equal. What about this point right there? Well, that's on the dotted line, and therefore it is not a solution. Points on that dotted line are not solutions to the first inequality, and therefore they're not solutions to the system. You must be a solution to both in order to be a solution to our system. And then what about where they intersect? Well, where they intersect, it is on a solid line, but it's also on the dotted line. Solutions to our system are only points that are found in our shaded region or on a solid line bordering our shaded region. And that's what you have to remember for our system and what points make it true and what points don't. All right, let's take a look at 959. 959 now has our boundary parabola and a boundary line. Notice we can identify the two. First off, I can look at the x squared to know that the blue inequality is going to represent my parabola. I could also look at my symbol less than or equal to, meaning it's going to be a solid line, or in this case, a solid curve. I can also identify that my pink one here is going to be my line because it's y and 2/3 x, so that's a linear equation. And I can also notice my inequality here is just greater than, and therefore it's going to be a dashed line. So that's how I can identify the two. And notice they've marked off different sections here. I want to point out what the sections are just so you're aware as we go forward here. And I'll just mark them off in different colors here. I'm just going to go highlight. All right. Section 1 is everything over here. All right. It is on this side. Notice it passes right through that x axis there. All right. So this is my section 1. All right, my section 2, I'll go in blue here. My section 2 is everything in this region right here. All right, and then my section 3, I'll go with this green here. Everything up in this region. Section 4 is in this little spot. All right. Now notice very carefully the x-axis and y-axis do not create our boundaries. Notice what's creating our boundaries. Our boundaries are only determined by what is beneath the parabola, above the parabola, and then also beneath my line and above my line. I'm going to come all the way around here. This boundary is the biggest one. Goes all the way up there. And this is everything beneath both, so this would continue on. All right, so it's that whole section there. All right, there we go. All right, so those are our 5 different sections as we're doing this, and what we want to do is we want to examine the two inequalities and look at their symbols to decide is shading going to be above or below each of our boundaries, and then put the two together to see where the overlapping region is going to be. All right, so let's go ahead and do that. Looking first at my parabola, I see that it's less than, and therefore I can go to my parabola, any point in there, and I can just draw lines that are less than. So less than my parabola is going to be beneath, down to this section. Notice less than goes into section 1, 5, and 3. Less than my parabola is in sections 1, 5, and 3. Then taking a look at my line, I see that it is greater than my line, so that's going to be starting at my line and going everything above. Notice it's in section 1, 2, and 3. So what's my overlapping region? What's my final solution region? And I'm going to put this here. Let's go for, I will go for black. All right, my final solution region, all right, is going to be this overlapping section right here in number 1. And this overlapping section right here in number 3. All right, so there are 2 overlapping sections that are my final solution here. All right, and that's where I would make my final shading. I got a lot of shading on here, and I'll take that off as we go to the next one. but I just want to make sure you know all the regions and what they look like. So that's how I check my overlap. But let's take a look at 60. What about this one here? Now all of a sudden, we are doing two that are greater than, all right, so we've got greater than or equal to the parabola. Well, the parabola is here, so greater than or equal to the parabola is above. So that's everything up in this region here above. Notice it's section 4 and section 2. All right, that's everything above my parabola. All right, and let's check my line. I also want everything above my line. Well, above my line would be everything here going from the line and up. Notice that's sections 1, 2, and 3. All right, and therefore my overlapping section, which we can see in the middle here, is going to be this right here. It's section 2. Section 2 is where they overlap. All right, and that would be my solution region. What if we change it now in part B? We've got a greater than or equal to for my parabola, but we have a less than my line. So let's do my parabola again. We said greater than is everything above the parabola, so I just go to my parabola and do everything above. All right, so my parabola is my boundary there, and everything above it would be shaded, giving me sections 2 and 4. All right, and then my line, I'm going everything less than my line. So I'd start at my line, here's my line right here, and everything less than my line would be below. And I see that's sections 4 and 5. So where is the overlapping section? Our overlapping section is right here in section 4. All right, and that's the part that you would shade. You don't have to have all the other shading, but you do have to have the shading for the final solution region. Let's take a look at the last one. All right, take a look at C. Now all of a sudden we are less than both. Less than both, well less than, here's my parabola. And less than that would be everything beneath that parabola in sections 1, 3, and 5 as we looked at earlier. All right, my line, it's less than my line. Well, here's my line. And less than my line is everything beneath that line. All right, shading in sections 4 and 5, which gives me my final solution region here is section 5. This is where they overlap down here. Then it follows along the parabola, back to my line, and then down here again. And everything beneath that, all right, is what we would shade. And that would be my final solution region, region 5 here for 960. In closing, I want to remind you of two things. One, there's going to be special cases, and I want to look at that here. And two, how can you use your graphing calculator to help us out? Well, to use your graphing calculator, and this is not your graphing calculator, this is Desmos, but I am putting in inequalities here, and I want to remind you how we can put these symbols here into our inequality. And if we go back to our graphing calculator, we notice that we will see these symbols right there. Let me get a pen there. All right, we will see these symbols right here if you scroll over to the left. All right, so when you're plugging in yours, you're going to have your y here, and it's going to say like y1, all right, and we're going to say y1, and it's going to say equals, and if you move all the way over, you'll see this little solid line here, and if you move your cursor over to it, and then while it's blinking on there, you hit enter, it will toggle through a bunch of symbols, all right, and you should come across these symbols right here. All right, this one here meaning less than, because my shading, I have my line and my shading is less than that line, just as a reminder. And then this symbol here would represent greater than, where I have my line and then shading is above. So these two represent greater than. You cannot do an equals to on your graphing calculator, so you have to understand, are you going to be using a dashed line or a solid line? So that's something that you have to pay attention to. All right, so you can plug in some of these into your graphing calculator so that you can see what they look like as well and see how it comes across on your screen. Now let me show you what it looks like here. If I bring up these two, I'm just going to pull up two inequalities here. We can see our solution region. It's very similar to what we just looked at, where you've got a solid line, you've got a dashed line. But notice I put some sliders over here because I want to show what happens if I start changing my y-intercept. If I take that b value and I start adjusting that dashed line, it's going up and down, and notice they're still crossing, but it changes where that solution region is, but it's always that top right section. All right, so it doesn't change the section, it just changes how big it looks. And again, it's an infinite section, but still changes how it looks. What if we start changing my slope? Well, if I start changing my slope here, all right, it's going to change the angle, all right, and that's going to change where they overlap, because notice what if I come here, they start overlapping like that right there. All right, you can see that section. What if I have them parallel? All right, what if I have them parallel? Let's take a look at what parallel would look like. Let me get up to half right there. All right, there we've got two parallel lines. All right, and I want you to notice, is there an overlapping region? No. This is a case where we would have no solution. Because in this case right here, there's no overlap. Remember, if two lines were parallel, they never crossed, there was no solution to a system of equations. Now, all of a sudden, this shows right here, no overlapping region also means no solution. But what if they did overlap and they were parallel? All right, and I'm going to move this up here. What if, let's start off with -1 here. What if they're right on the same line? Well, I've got a dashed line and a solid line, so again, no solution because there's technically no overlap. The only overlap is a dashed line and solid line, but on the dashed line, it can't be true. But what if I move up higher? Now, all of a sudden, I'm in this range right here. Now, all of a sudden, this is not no solution, but rather, this has a solution region. My overlapping region is right here in the middle. It's a nice parallel line, but I've got an overlapping region there. It's right in the center, and that would be my solution region. Now, what if I change this? What if I made this greater than? Now, all of a sudden, I've got an overlapping region with parallel lines, but it is above my one line. All right, and we can see here that this right here would be the only section we need, which means you technically only need my blue inequality for that. All right, so as we see that, they are going up together, and that's my overlapping region when I graph it. And what if I move my y-intercept down? All right, now all of a sudden that it's lower, now we can see my overlapping region is everything above my red line up in this area right here. So again, we're looking for overlapping regions, okay? You want to find an overlapping region where they meet. That is our system of inequalities. If they do not have an overlapping region, they have no solution. But other than that, they've got one, okay? Thanks for watching. Good luck.